Much of the country is experiencing an intense winter chill. Questions are being raised about what is driving these extreme conditions and what they tell us about our changing climate. Let's understand better now and look at the science behind the cold and snowfall and how scientists predict extreme weather patterns. And we speak to Dr. Nkanyiso Mbatha, researcher and group leader for climate and air quality modeling at the Council for Scientific and Industrial Research. Good evening to you, Doc, and thank you so much for your time. So if just on the face of it, right, what is behind the current extreme cold and snowfall weather?
Yeah, good evening, good evening. Thank you very much for calling us. Basically, I think we have seen in many radio stations and everywhere where they are trying to explain what happened, but what we had is a very, very strong synoptic scale winter, system that has a combination that was involving things such as a cutoff low and upper air trough, and also the low pressure. That very deep low pressure came through and it hit Eastern Cape, moved towards the interior of the country, and it brings about the cold air. And that cold air comes with what is called upper air trough that happens in the upper and in the middle troposphere. So that very deep trough sort of injects cold air downwards and then creating this instability in the atmosphere where you have clouds coming. As it moves up, it means now you have cold air aloft, or a layer of air that is moving over South Africa. And as that air comes all the way and hit high-lying areas like your Lesotho and some areas closer to Lesotho Mountains in KwaZulu-Natal, Eastern Cape, then we have lifting. So the lifting plus the cold air that is coming up and this trough and the moisture that is coming up with rising air that is pushed up by the trough, it's what we have. And of course, if you are in Lesotho, in high-lying mountains like Lesotho, you have, freezing level close by.
And is it usual, because you do have people asking that, is it usual that we see this combination of snow as well as rain?
Well, as I'm explaining, so you need to look more at the trough itself. The trough itself, it is as deep as this one was, for instance. Then you'll have these conditions. Of course, if you go to the statistics backwards, you'll see that we normally do receive these at least once a year, especially recently. But we do receive a lot of cutoff lows that would not come with the cold air that reached even Gauteng area where we are, because of that layer of air that also had a very deep trough. So it's something that is usual. I mean, it has nothing to do with climate change. It's just a weather event, yes.
And given the fact that, you've just mentioned climate change, you do have people who each time we see, just a weather system, change or drastic movement or extreme weather, you do then have concerns that then relate to climate change. So firstly, when it comes to the modeling, when it comes to the modeling of it and an understanding perspective to say, how then do we begin to marry the two, for example, to know that this is the weather, this is being impacted by climate change, but also at the same time for those who are communicating, for example, the early warning systems, to be able then to communicate a bit more clearly so that people kind of know the difference?
I think you want to know how we model these extreme. But of course, I'm not saying climate change is not there. Climate change will always alter with things like your temperature and the background condition. And so those background conditions, like your temperature, your moisture in the air, your wind pattern, circulation, and all those type of things, can change the conditions that you find, or the intensity and the spatial extent of snowing, for instance. So climate change can play a role in that. But when you want to know how these weather, or maybe these models, how we sort of look at these things, it's mostly, the issue is that the atmosphere, is very complex. So first of all, we always need to know what's happening in the atmosphere. We need to understand what's happening in the atmosphere. So that is by, using all sort of sensors that we can use to look at the atmosphere itself. The more we get in the information, the better the models, because whatever we use, for instance, your radars, your ground-based stations like South African Weather Service stations, your satellites. Recently, we have very good satellites that are able to see these events as they are coming from distance. You combine all the type of data, including even ocean observations. So all those are used as initial conditions in models. And of course, you can then change those initial conditions just to look at the uncertainty of the model itself and create what we call ensemble forecast. And stuff like that. So, and then in that way, if you're using all these things, you then inject that into the models we call NWPs, numerical weather prediction systems. Like, for instance, we like to use WAF, most of the people. And those models sort of help you solve physical equations that govern the atmosphere. And because you can't do it yourself, and you need very high, very big, like supercomputers. Thanks to the CHPC in South Africa, we managed to sort of run those models and to sort of understand this. So it means, with the understanding that we see from the conditions now and historically, we can use that to focus what will happen next. In that way, we become better in how we sort of forecast these extreme events, and because we learn them from the climatology, we learn them from the current events, and so on. So that is very important for us.
And as you say, I suppose then technology, as you say, does make things somewhat easier and quite to be able to know, where we're headed.
Yeah, a lot, especially because you can't run this using a normal computer. You need a high performance computer, very, like in South Africa, we have what we call CHPC, and of course, then you run those models there. And because remember, you are having a lot of data, and you are, using as initial conditions a lot of data from different sources. Some of it, or most of it, will be even 3D, like what we call ERA 5. You also have terrain. You also have your NDVIs and all sort of data that will sort of create this system so that we can be able to emulate going on in the atmosphere here.
All right, Doc, thank you so much for speaking to us. And I suppose the conversation is ongoing, especially even when one looks into the future. For example, what does climate resilient infrastructure also look like when it comes into the fray as well? But I appreciate your time. Thank you for speaking to us. Dr. Nkanyiso Mbatha is a researcher and a group leader for climate and air quality modeling at the Council for Scientific and Industrial Research, just really giving us a sense of how the modeling is done, and quite interesting to see what technology has been able to achieve.